Warning, the video you're about to watch contains mathematics at the level of integral calculus, also known as Calc 2. All material has an assumed prerequisite of differential calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is for calculus students, actually students in integral calculus, who are currently going through U substitutions or specialized trig integrals. And these are all the methods I'm talking about here, or have been talking about for quite some time, are just specialized U substitutions. That's all we're really dealing with here. In this video, we're going to go through a single example. That's it. So just evaluating an indefinite integral. If you take a look at what we have here, it's the integral of sine squared times the cotangent cubed of x dx. Now, thinking about our previous methods, we have direct integration. Well, you know that you'd be able to use direct integration if this was the integral of just the sine or just the cosine or something like that. However, it's not. You don't know the antiderivative of this just by looking at it. So we move to a different technique. The second technique that we learned was U substitution, and actually that could be a candidate here. And in fact, I went ahead and put a red X next to direct, meaning that that's not an option here, but U substitutions actually might work. It's not going to be so obvious to begin with, but it might work in the long run. The third method, if you're following my video series, that you could have learned to help you integrate would be integration by parts. The key to knowing when to use integration by parts is if you have a product of functions or possibly a single function you don't know how to integrate, but you could do a specialized U substitution in those cases as well. You definitely can see that this is the product of functions. However, it's the product of trig functions. And generally speaking, if you're going to use the by parts method and you're faced with the product of functions as your integrand, those functions should be different types of functions. What I mean by different types of functions are things like a mixture of exponential and polynomial functions, or exponential and trigonometric functions, or trigonometric functions and polynomials, that type of thing. But not trigs with trigs. That's really kind of a bad type of integral to deal with by parts. So I'm going to go ahead and cross out the by parts as an option. So really, the only thing that I have as an option right now is my old school U substitution. This type of example generally occurs after you've learned by parts, and it's to entice you to think about what you should be doing, not just to dive into the material that you recently learned, but rely upon older methods. And as I've said in lectures and in previous lecture videos, you should always perform mathematics in the order that you learned mathematics. That is, you should always perform arithmetic before you perform algebra, and then algebra before you perform trigonometry, and then trigonometry before you step into your calculus content. Well, in this case, I can use a little bit of trigonometry to simplify this statement. The cotangent, we know, is the cosine over the sine. So let me go ahead and rewrite this first. There we have it. Now, again, this cleans up beautifully because sine squared over sine cubed, that's just a sine in the denominator. And finally, you can easily see a U substitution is going to be very beneficial here. I'll allow U to be the sine of x so that du will steal away a cosine of x. Now, some people will say, why don't I allow U to equal the cosine of x? If you were to allow U to equal the cosine of x, then du would have to steal away a negative sine of x dx. But if you take a look at our integrand, we have a dx to steal away, but in that numerator, we just don't have a sine of x as well. So that would be a bad substitution. On the other hand, if you allow u to equal the sine of x, then du will steal away a dx along with 1 power of cosine. And I actually do have a dx and a single power of cosine to steal away. There's no need for me to show factoring out a single power of cosine. You could actually do that yourself. I will just do the substitution. When you steal away the single power of cosine and the dx, it gets replaced with a du. And downstairs, the sine of x is u. At this point, you should pause and realize you have an issue here. The issue is that you have an integral involving two completely different variables. You're integrating with respect to u. However, in your integrand there, you have a function of x. So you'll have to rewrite that function of x, hopefully, in terms of our substituted value for u. Remember, u is sine of x. Well, again, rely upon your trigonometry before you do any more calculus. So every single step that I do here, I'm going to go back and say, well, is there any algebra or trig I can do? And in this case, we can use a Pythagorean identity. We happen to know that cosine squared of x is 1 minus sine squared of x. And now we know also that the sine is just u. So I'll replace that sine of x with a u. And now using properties of arithmetic, again, not really using algebra here, or trig, or calculus, but actual arithmetic, I will break this fraction up into two separate fractions. And now I have a beautiful integrand, and I'll go ahead and integrate. The antiderivative of 1 over u is the natural log absolute value of u minus the antiderivative of u itself is u squared over 2. And don't forget, you have that constant of integration hanging out back there. Very important for indefinite integrals. Now, we didn't start this problem in the world of u's, but we have written our answer in the world of u's. So I'm going to go ahead and resubstitute what we know u is. U is the sine of x, so therefore our answer is natural log absolute value of the sine of x minus sine squared of x over 2, and then plus our constant of integration, c. And there we have it. That's the full antiderivative of sine squared cotangent cubed. Notice that I really focused on rewinding the tape, talking about our previous prerequisite content, trig, arithmetic, algebra. Work with those before you step into calculus. All right, that does it for this video. I hope that this clarifies any questions you might have for this content specifically, and I hope you have a wonderful day. Be a good human.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at ease. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.